Okay guys, in this video I want to look at some more theorems related to parallel lines and proportionality. So we have this theorem, if AD is parallel to BE, which is parallel to CF, and we have two lines that cut those lines, then AB divided by BC equals DE divided by EF. And so just want to prove this, and again, we'll prove these theorems and then we'll sort of do some examples in our next video. So what I want to do here is I want to draw a line from point A parallel to, let's call these lines M and N. So I want to draw a line that's parallel to line N and goes through point A. Okay? So I have that. Now we have two triangles here. We have triangle, we'll call this G and H. Okay, so we have triangle ABG is now similar to triangle, let's see, we have similar to triangle ABG, ACH, triangle ACH. Why? Well, we know if these two lines are parallel, then this angle and this angle, ABE and ACF, are those are congruent. We also know if these two lines are parallel and they're cut by a transversal, then these two angles are congruent. So by AA, similarity postulate, so by AA, then these are similar. So if they're similar, we can do the same process over here, right? I'm not sure I'll go through the whole thing, but if we have another line here that's parallel, then we can show that let's put a circle here. We know that these are congruent. We also know that, let's put a triangle here, these are congruent. So by sort of the same logic, then we can show that let's see, let's put J and K. So let me just write down what I've done here. Triangle DJE is similar to triangle DKF. Triangle DKF. So by similar arguments, AA. Okay. Now, basically then, this leads to this conclusion by the definition of similar triangles. Okay. So moving up here then, we have if AD and BE and CF are all parallel, and if AB is congruent to BC, then what it says is DE is congruent to EF. Now, I think this logic applies. We can take this theorem, we can put it into here. So if this is, for example, x to x, then we know that this must be y to y. We sort of apply the same logic that got us through this theorem, and we put it up here. So we know that if these are congruent, then these must be congruent to each other. Okay. Finally, if we look at this well, it's not super complicated, but it looks something like a ladder. We have many parallel lines cut by two transversals. Then we have many relationships, and I've just written out a few here. Okay, so for example, if this is our situation, we know that A to B is the same ratio as D to E. We know that A to C is the same ratio as D to F. We know that A plus B to C is the same as D plus E to F. Okay, I can write a few more. We know that, for example, we know that A plus C to B equals D plus F to E, and so on. We can do, for example, 5. We can do A plus B plus C is proportional to D plus E plus F. Okay, is equal to any of these. You could say A to D, for example. So there are many proportions and that you can write here. There are probably more than 10, but I won't go over all of them. But this sort of logic, is using all of this stuff we've talked about. In our next video, we're going to look at some examples applying these concepts, and hopefully through that, you guys can get a real solid understanding of this. Thanks for watching, guys.